In this video, we will talk about cofunction identities in trigonometry. So there are 6 cofunction identities, and I've listed them out here. The cosine of theta is equal to sine times pi over 2 minus theta. Sine of theta is equal to cosine of pi over 2 minus theta. Tangent of theta is equal to cotangent of pi over 2 minus theta. Cotangent of theta is equal to tangent of pi over 2 minus theta. The secant of theta is equal to cosecant of pi over 2 minus theta, and the cosecant of theta is equal to the secant of pi over 2 minus theta. So these are all written in radians, but it's worth noting that pi over 2, the equivalent in degrees would be 90 degrees. So let's work through a few examples of how to use these cofunction identities. So let's say we wanted to find the cosine of 55 degrees. Well, we know that the cosine of some angle is equal to the sine of pi over 2 minus that angle, or the sine of 90 degrees minus that angle. So what we can do is we can write the cosine of 55 degrees is equal to the sine of 90 degrees minus 55 degrees. So 90 minus 55, that's 35. So the cosine of 55 degrees is equal to the sine of 35 degrees. That's how we could rewrite the cosine of 55 degrees using a cofunction identity. Let's try another one. Let's say we have the sine of 80 degrees. How could we rewrite this using a cofunction identity? Well, over here we see the sine of an angle is equal to the cosine of pi over 2 minus that angle. So what we can do is we can say the sine of 80 degrees is equal to the cosine, and remember pi over 2 is the same as 90 degrees. So we'll say 90 degrees minus that 80 degrees. So we get the sine of 80 degrees is equal to the cosine of 10 degrees. These two values will be equal, the sine of 80 degrees and the cosine of 10 degrees. Let's try another one. Let's say we have the tangent of pi over 4. How could we rewrite that using a cofunction identity? Well, we see over here that the tangent of an angle is equal to the cotangent of pi over 2 minus that angle. So we can write the tangent of pi over 4 is equal to the cotangent of pi over 2 minus pi over 4. So to simplify these fractions in the parentheses right here, we can try to get them to have the same denominator. So in other words, how can we make this pi over 2, how can we make it have the same denominator as 4? Well, we just need to multiply the numerator and the denominator both by 2. So we could say cotangent of, if we multiply the numerator by 2, we get 2 pi. And if we multiply the denominator by 2, we get 4. So 2 pi over 4 minus pi over 4. And now, since these two fractions have the same denominator, we can just subtract the values in the numerator. So we're left with cotangent of 2 pi minus 1 pi, that's just 1 pi. So pi over 4. So the tangent of pi over 4 can be rewritten as the cotangent of pi over 4. These two values will be equal. Let's try another one. Let's say we have the cotangent of pi over 12. How can we rewrite that using our cofunction identities? Well, we see that the cotangent of an angle is equal to the tangent of pi over 2 minus theta. So we can write cotangent of pi over 12 is equal to the tangent of pi over 2 minus pi over 12. So once again, let's see if we can get these two fractions inside these parentheses to have the same denominator. So how can we convert this denominator, this 2, into a 12? Well, we could multiply by 6. So we can multiply the numerator and the denominator by 6. So let's do that. The tangent of 6 times pi, that's 6 pi, and 6 times 2 is 12. So now these two fractions in the parentheses have the same denominator. So we can just subtract the values in the numerator straight across. So we're left with the tangent of 6 pi minus 1 pi, that's 5 pi. And that's over 12. So the cotangent of pi over 12 will have the exact same value as the tangent of 5 pi over 12. Let's try another one. Let's say we have the secant of 13 degrees. How can we rewrite that using our cofunction identities? Well, we see that the secant of an angle is just equal to the cosecant of pi over 2 minus that angle. So we can write the secant of 13 degrees is equal to the cosecant of 90 degrees minus 13 degrees. So 90 minus 13, that's 77. So we're left with the cosecant of 77 degrees. So the value of the secant of 13 degrees will be equal to the value of the cosecant of 77 degrees. All right, let's try one last example. Let's say we have the cosecant of 5 pi over 14. How can we rewrite that using our cofunction identities? Well, we see that the cosecant of an angle is equal to the secant of pi over 2 minus that angle. So we can write the cosecant of 5 pi over 14 is equal to the secant of pi over 2 minus 5 pi over 14. So once again, just looking at the fractions in this parentheses here, how can we get these two to have the same denominator? Or in other words, how can we get this fraction to have a denominator of 14? Well, we'd have to multiply by 7. So if we multiply the denominator by 7, we can multiply the numerator by 7 as well. So let's do that. We get secant of 7 times pi, that's 7 pi. 7 times 2, that's 14, minus 5 pi over 14. So we get the secant of 7 pi minus 5 pi, that's 2 pi. So 2 pi over 14. And if we'd like, we can reduce that by dividing the numerator and the denominator by 2. So we can get pi over 7 as our final answer. So the cosecant of 5 pi over 14 will be equal to the secant of pi over 7.